Okay, so for today, we are going to talk about your Smith chart, which was developed by Philip H. Smith and T. Mitsuhashi around January 1939. So, long time ago, ang aton nga mga transmission media or transmission lines, they have your impedances described by resistive and reactive components. Not long ago, asa subang mo gina siya ya. Galing because it's as you can see, it's a complex number right here. They had to resort to advanced math to solve it. But with your Smith chart, tapos na lang pangitaon ang pag-match sang impedance naton. Just remember that, of course, ang atong nga plus, that will be your inductive reactance and minus is your capacitive reactance. If your transmission line is inductive, then dapat mabawi ka capacitive. And vice versa. Okay. And yep, let's look at some modern types of or modern uses of Smith chart. So, subong medyo computerized na kita. Here's one that looks like an oscillator. Kung nahiglaw na ako sa oscillator. This guy is an HP 8720A nga network analyzer. I found it in Wikipedia. It's based on the Smith chart. Ang ato nga graph dire. Here's another one. This one is an RF impedance matching software by Black Hat Systems. Ginabaligya nila for $19, as you can see. Still based on your Smith chart. And lastly, another one I found in a forum. It's the Genesis software. It's a network analyzer, but it still makes use of your Smith chart to balance or to match impedances. So, amo na siya. Sa aton subong, pen and paper kita sa pag-solve sa aton nga impedance matching. Okay? Let's look at your Smith chart. So, let me just repeat this para may backup kita. Okay. So, this is your Smith chart. This whole circular thing here. And let's zoom in on its parts. Okay. So, sa babaw, sa aton nga circle, all of those values are going to be your inductive reactance component. Okay? Sa babaw, tanan nga ara sa horizontal, sa left na side, is your resistive components, resistance components. Okay? Ang tanan nga ara sa dalom are your capacitive reactance components. Okay? So, plus babaw, minus sa dalom. Sa horizontal resistance, kag diri sa may left nga side sa horizontal, hindi lang siya ginsulat, pero diri na siya naton makita ang standing wave ratios, SWR. Okay? Now, sa may outer nga part sa aton nga circle, sa circumference niya, you can see here wavelengths towards generator. So, all these tiny numbers here, 0.04, 0.05, 0.06, etc. Those are like 0.04 lambda wavelengths pakadto sa imo nga generator. And then, on the other side naman niya, that is moving clockwise. If you're moving counterclockwise, then those are wavelengths towards the load. So, ari sila, oh. Yeah, the opposite case is this sa my right side. Let's see here. So, towards the load, towards the generator, you are looking at angles of reflection. So, it's as if nakagwa ng imo nga signal pagbalik niya sa generator. So, that's angle of reflection. Meanwhile, ang pakadto sa load mo, so you are still transmitting, you are looking at angles of transmission. Okay? And those are the tiny little values here. So, that's negative 20 degrees, negative 30 degrees, negative 10, negative 15, up here, 20, 10, stuff like that. Okay. Important man, guys, ang center sa aton nga Smith chart. So, yep. Friend ta ni siya. And then, down here, sa pinakadalom, if you already found out your standard wave, your standing wave ratio, pwede mo na makita ang imo nga losses. So, you have all the attenuations here, standing wave losses, all of those losses. Pwede mo makita dire. Okay. So, let us rewrite these. Hopefully, madumduman to sila. So, tanan nga pa sa babaw, XL or inductive reactance. Okay. Tanan nga pa sa dalom, XC or capacitive reactance. Tanan nga horizontal nga pakadto sa left are resistive components. Okay? tanan nga mga values sa horizontal nga pakadto sa right are standing wave ratio values. Okay. And then it's not really mentioned a lot of times ang angle of reflection and angle of transmission, but still useful, no? Ang per megagwaya is if you are moving clockwise, so that's 2 generator. Okay, lambdas na sa mga value. And then if you are moving counterclockwise, so those are 2 load kag mga lambda values man sa Japon. Okay? So, yeah, that's basically your Smith chart. Now, let's plot something. Let's plot something. Right na danay sa purely resistive load lang danay. So, what if ang load naton is 37.5 ohms? Ang characteristic impedance ng ato nga coax is 75 ohms, no? Yeah, by the way, this problem is based on a Tomasi example. So, we have that. The first step, guys, is to normalize. Okay. And when we say normalize, that basically means ZL over 70. Like, look for the ratio of your load impedance to your characteristic impedance. This is why the Smith chart that we are talking about in this subject, in this course, is called the normalized impedance Smith chart. There are other types of Smith charts like your normalized admittance Smith chart. But yeah, that's what we're going to use here. Okay, so number 1 is to normalize, no? So with that, ang aton nga Z nga i-plot karon sa Smith chart is 37.5 over 75. This should give us 0.5 ohms. Wala pa kita sa reactive components. So, laban-laban sina. Ang aton nga plot is along the horizontal. 0.5 to, di ba? So, 0.5 man kita masulat. Ari ang 0.5 sa horizontal naton. Okay. So, yeah, actually, we have finished doing step 2, which is plot. And step 3 is to draw a circle. That's why you're going to use a compass. And step 4 is enjoy the values. Yay! Don't. Okay, how are we going to draw the circle? There you go. Now, our circle will have the center, of course, in the center of your Smith chart. The radius is from the center of the Smith chart to the to the point that you have plotted. So, dirito circle. Tansya lang namin. Oops. Hindi mo. Okay. Struggle is real. Oops. Gamay pa. Dako pagiguro ni. Nan. Dupay gamay. There you go. So, hey. Stroke path. Okay. So, this is the circle that we have plotted. How do we enjoy the values? Okay, we enjoy the values like this. First of all, ang diri nga part ko, this is your SWR. So, natakluban ko lang. Sige na gani, huksan ko na lang. The SWR for this transmission line, which is 37.5 in impedance, is 2.0. Yay! So, siya balata ng SWR. Another thing na pwede nyo ma-enjoy is this. All the values along the circle that we have drawn are going to be the impedances across the transmission line. So, for example, you are being asked, ano ay ang impedance 0.12 lambdas towards the generator? So, question. Oopsies. Question AB. 1. Sa 0.12 lambda towards generator, ano ang iya nga impedance? So, what are you going to do? Look for 0.12 dito sa babaw, moving clockwise. So, I can see here, I see 0.12. Okay. Amo ni siya. So, I will draw a little circle diri para ma-notice, ano? And then, draw a line from point 12 pakadto sa imo nga center. So, medyo kiwi lang na siya, pero kayuhon ko na siya. Lagi na. Okay. Oops. There. Perfect. Okay. There. And then, ang inyo nga intersection from the line that you have made pakadto diri sa aton nga circle is this. Ari siya. This will describe the impedance sa imong nga transmission line 0.12 lambdas towards the generator. So, reflection niya na ni. Ano na siya ang iya sina nga impedance man? So, medyo mabasa kita gamay, no? Ang aton sini nga resistive component is duares tunga daw. So, around between 0.7 and 0.8. So, let's say it's 0.75. Dason, ara kita sa babaw sang hemisphere. So, that's plus. And then, check naton kung ano naman iya nga value sa inductance. So, do lapit-lapit siya sa 0.6, tunga sa 0.5 kag 0.6, pero do mas lapit sa 0.6. Nga dirigor na yan nanan. So, that is plus, ang balon to siguro mga 0.57, yeah, J ohms. Yeah. So, you can say that 0.12 lambdas towards the generator, ang impedance na nakakita natin is 0.75 plus 0.57 J ohms or J.57 ohms. Inductive kita. Yeah, however, remember nga ang aton sini nga value is normalized. So, duka gamay siya para mangin actual nga resistance kag reactance. So, we have to return it to its, original nga value. So, kagina, nag-divide kita sa 0.75, so buong multiply naman kita sa 0.75. So, I need space. I-reason ko yung nanay. Okay, so the Z that we have solved was 0.75 plus 0.57 J ohms. Para mahukas ang pag-normalize sa iya, multiply ta siya balik sa ZO, 175. And that should give us 56.25 plus J, 42.75 ohms. Okay. So, this is the impedance that we are looking at sa 0.12 lambda towards the generator.